Today we are going to perform experiment on heat exchanger. Heat exchanger is a device which facilitates the heat transfer between two fluids which are kept at different temperatures, between hot and cold fluid. For example, car radiator. There are many examples in practical field. So the tube, you can see here there is a geyser. The water coming is get heated by this geyser, and this geyser, the water outlet. This is the inlet outlet of the geyser. Outlet of the geyser is connected with the inlet of the hot tube, which is colored with red color. This hot water, the inlet hot water, and the hot water gets coming out from this tube from this side, and this is a concentric tube in which the hot fluid is flown in the inner tube, and the cold fluid is flowing over the cold fluid, that means surrounded the hot fluid. And this is a concentric type of tube. And with the help of these valves, we can change the flow of the flow direction. Because in this setup, we are going to perform two experiments. Perform the experiment on heat exchanger of two types. The one is the parallel flow. The second one is the counter flow. In parallel flow, the hot fluid and the cold fluid flow in the same direction, while in counter flow, both fluids will flow in opposite directions. And the direction of the flow in this setup is going to be controlled by these valves. What happens here, the water is coming from this side into the tube. First, the direction of the hot fluid is constant throughout the experiment. It's not going to be changed. It is constant. It remains from this side to this side. The flow of hot fluid occurs from this side to this side. This is fixed. If suppose that if we want to have the parallel flow heat exchanger, then we have to cold fluid. We have to a flow of cold fluid in the same direction from right to left side. So what will we do? The water is coming from here. We will stop that water by moving. That means closing this valve. This valve is closed, and then the water is constrained to move in this direction. So we are going to open this valve to make it parallel flow. And the water is going inside, it's coming inside through this tube and flowing in this direction and coming out from this direction. This valve is closed. That means the water will flow out from this tube. In that manner, we will achieve a parallel flow heat exchanger. Now, for the counter flow heat exchanger, as we know, the flow direction of the hot fluid is in that direction, in this direction, from right left in this direction. So we have to achieve a flow of cold fluid in opposite direction. So what is the water coming in from this side? So what we will do, we will close this valve, and the water is constrained to move in this direction. So we will facilitate by opening this valve to move a cold fluid in this direction, and we will close this. We will close this valve. So the water will move in this direction, and after this the cold water move in this direction, which is opposite to the hot fluid flow direction. So then the cold water will come out from this tube, and this valve is closed, already closed. So this valve should be opened to have cold water outlet. So in this manner we will achieve the counter flow heat exchanger setup. In both setup, what we are going to find out the overall heat transfer coefficient, LMTD, log mean temperature difference, and the effectiveness of the heat exchanger. Then we will have to find out the mass flow rate with the use of the beaker. That means we will calculate the time at which the beaker will filled up to 1 liter. That means the mass flow rate will be 1 liter divided by time, liter per second. It can be converted into required units. Okay. So in both cases we will find out the mass flow rate. After finding out the mass flow rate, we will try to achieve equal mass flow rate as possible. After calculating the mass flow rate, we will note down the temperature at the inlet and the temperature at the outlet for both hot and cold fluid. So these are the thermocouples which are embedded here. This and this. That means there are 4 thermocouple used here. So as we know, the hot fluid, the reaction of the hot fluid remains fixed. So this is a hot fluid inlet in both experiment, and this is hot fluid outlet in both experiments. And this thermocouple is cold water inlet for parallel flow and cold water outlet for counter flow. And this one is cold water outlet for parallel flow and cold water inlet for counter flow. How can we calculate? By using this temperature indicator. This is electronic circuit here. By using the electronic circuit, we will find out the temperature by switching the knob. As written here, TC1, this is 1, 2, 3, 4. There are 4 points written here. TC1 represents hot water inlet temperature, TC2 hot water outlet temperature, TC3 cold water inlet, TC4 cold water outlet for parallel flow heat exchanger. But in case of counter flow, TC3 and TC4 are interchanged. In this way we will observe the temperature of inlet and outlet points of both hot and cold fluid. Remaining is the calculation. After observation, we have to calculate the hot water mean temperature, which is given in this manual. Step by step we will calculate this.